Hello guys, let us start with one numerical problem here. Now this one is it's quite simple, but then it will enable us to find out different quantities like the maximum range and the maximum height reached, or then the time of flight and so on. Right? Let us try and read this. A cricket ball is thrown at a speed of 28 meters per second in a direction 30 degrees above the horizontal. Calculate the maximum height, the time taken by the ball to reach the same level, and number 3 is horizontal distance from the thrower to the point where the ball returns to the same level. Right, it's quite simple. You have been given the initial velocity, you have been given the angle of projection, you even have angle of projection and speed. What else do you need? You don't need anything else for that, right? The maximum height, so h, I remember that my h is equal to u square sine theta upon 2g, right? It is u square sine 2 theta. Sine height would be u square sine square theta upon 2g. Okay, and what is my maximum range? It is u square sine 2 theta upon g. So when I substitute my theta and initial velocity, I get the answer. Let's see what it is. It is 28 square multiplied by sine square theta. Your theta is equal to, so u is equal to 28 meter per second. I am writing it here, and theta is 30 degree, and so sine square 30. Sine square 30 would be 1 over 4 here, and divided by 2 into g would be 9.81. So it is 28 squared upon 8 into 9.81. You can calculate this with your calculators or any other means that you are allowed to in the exam, right? So that many meter would be the maximum height reached by this ball. Now what about the horizontal distance from the thrower to the point where the ball lands on the same level? Okay, here again I put 28 square and then that multiplied by sine of 2 theta. Theta is 30 degrees, so sine of 2 theta would be sine of 60 degree. That would be root 3 over 2 here, and then 9.81. Again you can calculate this. What was the second part? Second part is time taken by the ball to reach the same level. So in other words, they are asking for time of flight. And what was the time of flight? Was it not 2u sine theta upon g, right? So my time of flight is equal to 2u sine theta upon g. So that would be equal to 2 into 28 into sine of 30 would be equal to half, and then that multiplied by 9.81, and we calculate this and you get the time of flight as 28 upon 9.81 would be approximately a little more than 2.8 here, because 9.81, if you round it off to 10, and then 2.8 upon 10 would be 2.8. 28 upon 10 would be 2.8, but then it is less than 10, so it will be more than 2.8. So whatever answer that you get, that many seconds would be the time taken by the ball to reach the point where it started from, on the same level, correct? So that was a very simple problem. Maybe in the next video we are going to deal with little more exciting ones. Yeah, thank you so much.